Welcome to Flip Lesson 104. Today we're going to look at rounding decimals and how that works. And it's really a concept that really shouldn't be too different. We start by looking quickly at a review, just looking at our decimal places. We see tens, ones, and these are the things that we want to start making sure we have locked away in our memories, right? We have tenths, hundredths, thousands, and for this example, I'm going to go to 10,000s just to see how it works. But then we have our nice decimal place right here showing us the difference of these place values. And with any type of rounding, we're looking for a specific location, what we want to round to. And so if I wanted to round to the hundredths column, then what I need to do is I need to look back one place value. So if I'm rounding to the hundredths, if I'm trying to round to this value, I look back and I look at the 5, and the 5 tells me to round up. And so this 4 would become a 5. Right? And for another example, if I were to round to the nearest whole number, right, whole number being the ones place, I would look back past the decimal to the tenths, see a 3. 3 tells me to round down, and so this number would round to, simply put, 12. It would stay 12. And so we're going to apply that concept as we work through rounding decimals. This is very, very similar to rounding mixed numbers. So it says round to the nearest whole number. So we have this number down here, 1.35, or 1 and 35 hundredths. The question is, where does it fit on this timeline, on this number line? Is it closer to 1 or is it closer to 2? And in this case, as always, we're going to use the number 5 to help us find the middle. And by finding the middle there, we can say, okay, 1.5, right? If it's going to be greater than 1.5, we're going to round up. If it's going to be less than 1.5, we're going to round down. So now we can look at the comparison, right? We're going to look at place values, compare. So I'm going to look at the 5 here. And I'm going to look at the tenths place value. The 5 is a tenth. I got to compare it to a tenth here. And since the 3 is smaller than a 5, then we're going to say, okay, that means we're definitely going to round down to 1. So if we're rounding to the nearest whole number, we're going to be there. Okay? We're going to kind of ignore this. We're going to ignore any extra decimals because when we make comparisons with decimals, it's our tenths place or our largest number to the left that's going to be the value we want to see. All right. Then it says estimate the product of 6.35 and 12.6, right? So it says estimate and then solve. Product means multiply. All right, so I'm looking at the 6. I look back 1, right? And I'm going to estimate to the nearest whole number. 6, 3, that tells me this is going to stay a 6. Then I look at my 2, look back at 6, that tells me round up, so that gives me a 13. So I'm going to take 13 times 6, and I'm going to get that answer real fast. How about this idea? It says Zach saw this regular hexagon. That means all the sides are the same. On the door by the science lab. What is a reasonable estimate for the perimeter of this sign? Okay, so perimeter, regular, all the sides are the same, so that's going to be, 6 times the length of one side, or you could add the length 6 times. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I don't know. One of them didn't appear. Okay. However, we do know this, right? We know it's 4.5, but it says estimate, reasonable estimate. Make it make sense, right? So 4.5, we're going to round that. That's going to round up to 5. 5 times 6, or 5 added to 8, would be 30 inches for a perimeter. And is it reasonable? Does that make sense? Yes, that makes sense, right? We're not going to say 300. That wouldn't make sense. We're not going to say 15. That's not going to make sense either. Right? Reasonable. All right. Well, here's a sample problem for you to work with rounding decimals to the nearest whole number and then applying that to different formulas that we have learned. That's it for lesson 104.